All right, in Learning Target 5, the key here is that now we're dealing with real-world contexts and situations. Um, the key for this lesson anyway, and what I want you to focus on, is how to take a real-world context and write two equations that model it. I think once you've got those two equations, we've worked on in previous learning targets, we've worked on how to solve it, and then we'll kind of interpret what that answer means. So keep in mind the focus here is kind of less on the solving and getting the answer and more on the can you write the correct equations, and then once you find your answer, do you know what it means? So we're just going to run through a couple practice problems, and then you'll have a before class, and then we'll talk about it in class. So the first example, write a linear system of equations to model the real-world context. You can use it, or you can solve it using substitution or elimination, and then we're going to interpret what the answer means in terms of the problem. So the problem is Edna leaves the trailhead at dawn to hike 12 miles towards the lake where her friend Maria is camping. At the same time, Maria starts her hike towards the trailhead. Edna is walking uphill, so she averages only 1.5 miles per hour, while Maria averages 2.5 miles per hour walking downhill. The question then is where and when will they meet? And so kind of keeping in mind that question of when and where they'll meet is going to be key in how we think about this problem. So what those two things tell us, first you always have to identify what the question is even asking you to do. And we've identified that it's asking you to find when and where Edna and Maria will meet. And so that kind of clues us in on what our two variables are going to be for this equation. Okay, so we're going to have an x and a y. And we want to define these two variables. So we want to tell first what they what each of the variables is going to have to be based on what they're asking. Before we get into that, I think that a lot of times, for me anyway, it really helps to make a drawing or some sort of visual, because I read this and I see just a bunch of words and a few numbers, and I need to kind of see where everything goes. So the first thing that I usually like to do is to make a drawing. So it can just be something real simple, like we'll start trailhead down here, and then the lake we'll say is over here. Edna starts at the trailhead. Maria starts at the lake. And in between the trailhead and the lake is this 12-mile trail. Okay. We know that Edna, if we go back to the problem, Edna starts moving towards the lake, and she moves, since she's walking uphill, she walks a little slower, so it's 1.5 miles per hour. So Edna is going from the trailhead to the lake at 1.5 miles per hour. Okay. We also know from the problem that Maria is heading from the lake to the trailhead, and she's moving at 2.5 miles per hour. And they're going to meet somewhere here in the middle. We don't know where they'll meet or how long, and that's what we need to find out. Okay, so that's kind of the question that we're dealing with now. We need to know when and where. Those are the two things, so those are going to be our two variables. So the when can be answered by distance, or the where can be answered by a distance, sorry. The y can be the distance, and the x can be the time. Okay, so we answer that question of where, and we answer that question of when. All right. Go back to our drawing for a second. We need to, if we're going to talk about their distances, we need to have some sort of reference point. Okay, so we can't just say like the distance traveled, okay, because that's going to be different per person. So we'll say the distance from the trailhead as our reference point. So y is actually going to be distance from trailhead. And for Edna, she starts at the trailhead. Okay, so we're going to have like a +0 as our b or our y-intercept. She's starting at a distance 0 away from the trailhead. And each hour, she's moving 1.5 miles further from the trailhead. Okay, so this equation right here can represent Edna's distance from the trailhead. And then the equation representing Maria's distance from the trailhead will be y equals, she starts 12 miles away, okay, because that trail is 12 miles long. So she starts 12 miles away, and she's actually getting closer to the trailhead, so we're going to have a negative 2.5x. Okay, again, the reason that's negative is because the distance from where she's at to the trailhead is decreasing. Okay, so each hour that she walks 2.5 miles closer, so that distance is decreasing. So there is Maria's equation. Go back to this page. So you can write these two equations down in your notes. Here's Edna's, y equals 1.5x, and here's Maria's, negative 2.5x plus 12. And now you have a system of equations. Okay. Now we can go ahead and solve and find the time in hours and the distance from the trailhead. We can do this either by substitution or elimination. Since we already have y isolated by itself over here, it makes most sense to me to use substitution. So that's what I'm going to do. So I'm just going to go ahead and substitute this 1.5x in for y. Going through solving, add 2.5x to both sides. You get 4x equals 12, and then x must equal 3. Okay, so interpret what this answer means in terms of context. This is important. So we know x equals 3. Well, what does that mean in terms of the problem? That means that Edna and Maria will meet each other after 3 hours of walking. Okay, so you can go ahead and write that in somewhere. They will meet after 3 hours, or something along those lines. Okay. Then we can go ahead and solve for y. This is the easy part. Just take maybe this first equation, substitute in, you know x is 3, so we'll substitute that in right here. And y equals 3 times 1.5, which is 4.5. Okay, and then again, in terms of the problem, that means y, remember y is the distance from the trailhead, so they'll meet 4.5 miles from the trailhead. Okay. Our next example, Josh and Rachel sold cookies and brownies at a math club bake sale. The cookies cost 35 cents each, and the brownies cost 75 cents each. If they sold a total of 600 items and raised $360, how many cookies and brownies did they sell? So again, we need to look at what the question is asking us. It's asking how many cookies and how many brownies were sold. Okay, we know that the next thing I want to look at then is what we already know, like what the problem tells us. It tells us that a total of 600 things were sold. Okay, so if you want to say like our two variables are cookies and brownies, we know because of they sold a total of 600 items that x plus y equals 600. The amount of cookies sold plus the amount of brownies sold has to equal 600 because that's the total number of things they sold. We also know that they raised $360. So another equation we could write is that $360 equals the number of cookies sold times the price, 0.35 times the number of cookies sold, plus 0.75 times the number of brownies sold. Okay, and that's kind of the key here. Remember, X is the number of cookies, okay, and if each one sells at 35 cents, this 0.35 times X is the total amount of money made off of cookies, and similar for brownies. Add those two together and we know that they raised a total of $360, okay? So now we have a system of equations here. Now that we have that, we can go through and solve it. Okay. This is one where neither equation has an isolated variable. I think that could be fairly easily done with this first one. So I'm just going to go ahead and manipulate this one. If you see this and you think it's going to be a lot easier to do elimination, I'm fine with that. I could see how you would think that too. But I like substitution a little bit better, so that's what I'm going to do. Y equals 600 minus X. If I just subtract an X from both sides, I'll have this isolated for Y. And then I can go ahead and substitute that into there. So 360 equals 0.35 X plus 0.75 times 600 minus X. Okay, that'll give me 360 equals 0.35 X plus, use distributive property here, and you'll get 450 minus 0.75 X. Okay. From this point we can combine like terms. Over here we're going to get a negative 0.4x plus 450, and that equals 360. Subtract a 450 from both sides, and you'll get over here negative 90. Divide by negative 0.4 and you'll get X equals 225. So in terms of the problem, that means that 225 cookies were sold. Okay. We can go ahead and solve in for X then. Remember, the total number of items sold was 600, so if 225 cookies were sold, that means that 375 brownies had to be sold. So Y equals 375, and that is the number of brownies sold. Okay. So in terms of the problem, you can answer how many cookies and brownies did they sell with they sold 225 cookies, 375 brownies. Okay. For next time, I'd like you to do this before class. Okay. On a rural highway, a police officer sees a motorist run a red light at 50 miles an hour and begins pursuit. The instant the police officer passes through the intersection at 60 miles an hour, the motorist is 2/10 of a mile down the road. Okay, I'm going to suggest and very, very highly recommend that you draw a picture for this. Okay, for me, even it's tough to visualize this in my head. Okay, so I would really suggest that you draw a picture first. I think that will help you write your equations, and then you can solve them however you want after that. Okay.